But anyway, everybody, right here, may show, in other words, the Mobitz 2, characterized by skipping of QRS complexes, may show 2. Now, here's the deal. Okay, now here's what you got to say. Okay, Westmoreland, how do you know the difference between a Mobitz 1 and a Mobitz 2? How would I recognize that? All right, let me show you something. All right, I'm gonna say it to you, and then I'm gonna say it to you. It's on your book. All right, now right here, here is the Winky Bob right here. Now you'll have to look at it. Now if you look at this right here, see the PR interval right here is normal, longer. There's a T. There's a longer, and then it's going to drop. Anyway, it drops, but it starts normal, longer, drops one. Now here's the deal. All right, how do you tell the difference by looking at one of these deals with a second degree? Well, here's the second degree down here. Here's the second degree. All right, now in the second degree, everybody, here's the thing. Kind of embed this in your brain. All right, here's the way it works with a second degree Mobitz 2. How do I tell the difference between a Mobitz 1 and a Mobitz 2? All right, in this one, the PR interval is normal, and then maybe, longer, then it drops. All right, it's going to do the same. Here's the difference. It's going to drop QRSs, but here's the thing. When a P wave precedes the QRS, it's in the normal position. It's not any of this normal, longer drops. It's going to drop QRS. You follow me, Jamie? But when the P wave does precede, I mean when it doesn't drop a bunch, when it does precede a QRS, it's in the normal position. It looks normal. Now R to R will also be irregular though. R to R will be irregular. Did you kind of follow that a little bit? Look up here. P waves, see? P waves that are followed by QRS are in the normal bold printed position. P wave that is followed by a QRS that's normal. In other words, it's not greater than 0.2 of a second. It's in the normal range. However, there will be P, Q, R, S, T, P, 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 skipping these, then maybe P, Q, R, S, but it'll be normal. Now, you kind of get the idea on that? We're going to do this. We're going to look at these in the lab too. I have some questions in the lab we're going to do on these things. So you're going to get another dose of this in the lab, another dose. And I've got a woman in my... I don't have a woman. There's a woman in my 2401 class. There's a woman in my 2401 class who is an EMT. In fact, her name is Susie. And if I'm going to talk to Susie about, in fact, she works with a guy that I had in class who's with the Herman Life Flight group, which he's told me I can come fly with him. I'm going to fly with him. There's a heliport down in Baytown, and I'm going to one of these nights. His name is Jeff Cobb, and I'm going to fly on a life flight mission with him one of these days. I'm going to go down to Baytown and figure out it's supposed to be easy to find down there where it is. And he said, "You're welcome. You come on. I've already cleared it with my superiors, and you can do a life flight with me." It's a life flight out of Herman Hospital. But anyway, Susie works with Jeff. And if I could ever I'm going to ask Susie about the possibility of her bringing a portable EKG to our lab. And see, do like Abraham did, only she won't do Winky Bob over and over and over again. And see if we could, that'd be fun to hook you up to. That's what Abraham did. And in fact, that's where I got these EKGs showing the difference. See, with a machine, you can simulate different problems. You follow me? You can simulate different problems. You can simulate sinus rhythm. You can simulate first degree heart block. Simulate, that's where these things came from. These things came, everybody, things came, I've had these for a long time. These things came from the machine in the lab. Abraham made it simulate asystole, V-fib, a third degree heart block, and so forth. And so these are all machine generated. You know, what do you want to say? Like, okay, let's fake this. Let's simulate sinus rhythm. Let's make the machine do sinus bradycardia. This would be kind of like, this one right here would be, I've had them turned upside down. This would be kind of like Lance Armstrong right here. That's sinus bradycardia. That's an abnormally slow heart rate. Abnormally slow. Now I'm going to teach you how you count. See, you can count a heart rate, Brett, and that's what you're going to have to do on the lab test. You're going to have to determine heart rate from one of these sheets. And I'll tell you how to do it. I'll tell you how to do it.